Okay, so this is the second video in analyzing the hookup culture data. And so one of the things I wanted to be sure to show you was just to save things, you want to go up under File and hit Save or Save As, but since it doesn't name, I'm going to hit Save As. And then you're going to, of course, want to specify the correct folder, and I'm just going to call this hookup, sorry, I have to just think of a name here, hookup culture data cleaning and oops, sorry. And demographics. And we'll hit save. And I think giving it a descriptive name is a really good idea. So we're going to hit OK. And I'm also going to give the data set a new name. So I'm going to do save as, and I'm going to call it attitude. So I'm just going to call it hookup. Hookup data or analysis, and hit save. That way I still have the raw data. I want to do something with it. So then the next step obviously would be I want to do two things. I want to select out those cases, and this is why I'm doing this in a new file. I'm going to select out those cases if who actually have data, who actually collected data. So I'm going to go up under data, and I'm going to scroll down to select cases. And again, I'm going to use a conditional term. So if the condition is satisfied, and what I'm just going to do is I'm going to say if experimental condition is greater than or equal to 1. And I'm going to hit continue. And so what that's going to do is it's going to eliminate, and what it says is you can either filter out unselected cases or you can delete. And in this case, I'm going to delete the unselected cases because these are people that basically didn't give us enough data to include them in our analysis. So I'm going to hit OK. And we're now down from, again, notice that SPSS is recording everything that we're doing. So if we go all the way down to the bottom now, we were at 170 some cases, and now we're down to 136. And I'm going to go again, and this time I'm going to go to data, select cases, and I'm going to say if, and in this case, instead of saying if that condition, if there's data in the condition, so essentially that if experimental condition is greater than or equal to 1 basically says, is there data in that field? I'm going to do MC correct. And in this case, I just only want to include those people who answered the manipulation check correctly. So I'm going to hit MC correct equals 1, which is what we specified, correct? I'm going to hit continue again, and I'm going to hit OK. And so that's going to filter out that's going to remove a few more people from the data set. And so now we're down to a sample of 125, which actually isn't that bad. Now, as I mentioned earlier, and I'm going to hit save because I like to save in between things. So what I told you before is we looked at what was the distribution. It looked pretty even. What I want to do is now go back and run those descriptive statistics again. Since the only ones we're including are people who answered the manipulation check correctly, we really only want to look at the experimental conditions. So we're going to hit OK, and I'm going to expand this window. And now we still have roughly equal numbers. So we have 38 in the feminine group, slightly fewer because they seem to make the most mistakes, 44 in the masculine group, and 43 in the neutral group. But that's actually a pretty good distribution. Would be ideal if we had closer to 50 in each group, but this is actually a pretty decent size sample overall, and I'm pretty happy with that. So we're going to hit save. And I'm going to minimize that. So then the next step is going to be to check on the demographic characteristics of our measures. So if you recall, last semester I talked about measures of internal reliability, and the idea was that internal reliability was a measure of how well correlated the items in a given measure were with one another. And so the first thing we want to look at is the intercorrelation, so the internal reliability of the measure that we made up, which was the semantic differential. And it looks like, if I'm not mistaken, that the positive that we didn't have, we didn't need any of them that needed to be reverse scored. So items on the low end were positive items and items on the high end were negative items, suggesting that higher scores would be associated with a more negative attitude, which is sort of the direction we were going in. So what I'm going to do is I'm going to hit Analyze, and I'm going to scroll down to this window called Scale, and I'm going to scroll over to Reliability Analysis. And then what I'm going to do is I'm going to select the items. And I believe that it would be these guys. Select, so it's Q18. I'm going to select all of those items, and basically what I'm doing is I am holding Shift down once I select the first one, and I can just use the down button to select all the items I want to include in the analysis. I'm going to use this little arrow to move them over into the items box, and then I'm going to give them that scale a name, which I'm going to call semantic differential. And then I'm going to go up here under statistics, and I'm going to tell it that I want the item, the scale, and the scale if deleted. And what that's going to tell me is how well correlated are each of the items and what will happen to the internal consistency of the measure if I were to remove one of the items. Because sometimes an item doesn't correlate well with the others, and that brings the scale reliability down. So we're going to take a look at that. So I'm going to hit continue, and you'll notice here model. Its default is alpha. There are other options. I'm going to use the alpha because that's the statistic that I want, which is called the Cronbach's alpha coefficient. And I'm going to hit OK. And actually, so typically we think of an excellent internal consistency of 0.8. The internal consistency of a scale tends to go up with more items, but we got a Cronbach's alpha of 0.77, which I think is really, really good, just considering it's a measure that we developed. And all that really is telling us is that we are within our rights to put the scale to summarize these items together. So one of the things you're going to notice here in this table is the item total statistics. So this is the scale mean. It will change a little bit if you remove an item. Scale variance if the item's deleted doesn't seem to have a big impact on that. It's corrected item total correlation with the entire scale, but what's particularly interesting, and the thing I always look at, is what happens to the overall Cronbach's alpha coefficient if I were to remove an item. Now, if removing an item brought the scale up to above a 0.8, I would say it would be worthwhile to remove the item. But you'll see here that these 4 items would actually lower the Cronbach alpha coefficient, so they really hang together well. And there's this one that might bring it up, but it's only bringing it up 0.004. So what this tells me is that overall these items are hanging together pretty well. So we're going to create a summary score. And I tend to prefer means as opposed to sums, because that will actually allow me to, well, I'm just going to compute that. So one of the things we're going to notice is that when I'll back up. Sorry. So I'm going to create a summary score. I typically do averages, means instead of sums. That tends to be my preference, although we can do sums. Obviously, sums give you a wider amount of variability. But overall, if you were to look at the associations, it's not going to change it that much. So we're going to hit compute variable. And in order to, so you'll notice here that it saves the things that we did last. So if I want to start this process over, I just click reset, and that's going to set this back to the default. So I'm going to call this, I'm going to go in here into target variable, and I'm going to give it a name, which I'm going to call it semdiff, which is our semantic differential. And I'm going to say mean, which is the command to SPSS that it should calculate the average. And then I'm going to move each item individually over and separate it by a comma. Now there's 2 ways to do this. You can do this the slow way, or you can go down and select it and then double click and it'll just pop right up. But you'll notice that I'm putting a comma in between each, and then I have a parenthesis. So the command is mean, open parentheses. Each of the items I want included in the sum, in the target variable, in that average, separated by a comma and then an end parenthesis. And that's it. And I'm going to hit OK. And again, like I said, SPSS saves all that. I'm going to save this because this is a record of what we've done. And then again, SPSS saves all of the new variables at the end of the data file. So we now have our mean semantic differential score for our participants. And you'll notice we actually have very little in the way of missing data, which is good. So the people who we kept, most of them at least answered all of those items with the exception of a handful of folks down here. Okay, so that's the first thing. Now we have a bunch of other scales that we need to look at. And I'm going to do the same thing with the remaining scales. So we have the sex roles questionnaire is the next one. And let's see. So one of the things I'm going to have to look at with that is that in the sex roles questionnaire, there might be some that need to be reverse scored. So I'm actually going to do that one later. But let's see if I can figure this out. All right, I'm going to pause this for a second. Okay, so in the sex roles questionnaire, there were 4 items that need to be reverse scored. So in most of the items, high scores were represented by a more traditional sex role perspective, but there were 4 that are more gender neutral. So in order to make them all align, what we're going to do is we're going to recode the 4 items that align with a more egalitarian gender role or sex role perception, so that higher scores represent more traditional values. All right, so we're going to do that by going into transform. And we're going to scroll down to, I'm going to do it recode into same variables. We have the option to do it in the same or different ones, but since I saved the raw data, I'm okay with doing it this way. So click on recode into same variables. And I'm going to scroll down to those items, which are, if I hover over it again, this is going to give me the right answer. So I'm going to select those items. So it was 1, 2, 3, and 5. And I'm just going to make sure that I have all the right ones. People can be both aggressive and nurturing. People should be treated the same regardless of their sex. Freedom the children are given should be determined by their age of maturity. And we should stop thinking about whether males or females. Okay. And so now what we're going to do is we're going to reverse score. So we're going to hit the old and new values. And so to do that, we're going to say, put in the old value 1 and in the new value 10. And we're going to hit add 2 in the old value, 9 in the new value, hit add 3 in the old value, 8 in the new value, 4, 7, 5, 6, 6. Yeah, this seems like they could just put a little button, but they don't. 7, 4, 8, 3, 9, 2, and 10, and 1, and hit add. And then I would just double check it because all the values are here. So 1 to 2, 2 to 9, 3 to 8, 4 to 7, 5 to 6, 6 to 5, 7, 4, 8, 3, 9, 2, 10, 1. Yes. And once we've done that, we can hit continue. And now what it's going to do is we'll hit OK. And what's going to happen is it's going to reverse score that scale for us. Now, the reason we need to do this is because our Cronbach's alpha coefficient will look lower if we have items that are scored in the opposite direction of the rest of the scale. So now that we've done that, we can run our Cronbach's alpha coefficient. And then I will save this and show you other things that you need to do, but I'm out of time on this particular video.